I like science, obviously, and that's why I watch science shorts on my social media. And every now and then these social networks show me something that scares me a little. Infinite energy machines. You yourself may have seen some version of these videos on your social media. The innocent version of this idea is that toy that keeps tossing a little ball in loops over and over again. The less innocent version is videos of motors in strange configurations, apparently disconnected from any energy source, and producing electricity and powering lamps and other household appliances. The creators of these videos suggest that they are producing energy basically for free. Some channels even make video series showing the secret of infinite energy. It's incredible in the semantic sense of the word. Incredible, not credible. It's hard to believe that these machines produce energy as their creators claim. If there's one thing science has discovered in centuries of inventing all kinds of conceivable engines and energy generators, it's that generating free energy is not possible. Claiming that generating infinite energy is possible is a lie. And what scares me is that I want to believe. I want to be convinced. I want to think it's possible to create an infinite energy engine. More than a cheap energy source, such an engine would be evidence that it's possible to escape the certain future of everything that exists. We live in a world of slow but constant degradation. Machines rust and stop working, batteries run out and become worn out, and our own bodies lose the ability to regenerate as we get older. Engines do not produce infinite energy because everything has to end, even useful energy. The search for the perfect engine, for an engine that works forever and creates infinite energy, is a struggle against the tendency of degradation in the natural world. And a part of me wants to escape the slow march of time. And the other knows that this is not possible. Yeah, you thought there wouldn't be an existential crisis in this video, right?
Hey, Pedro here. This video you are watching was originally in Portuguese, my native language. This is the attempt of our team to translate it to English, and I sincerely hope you enjoy it. Your feedback is extremely important to us. Now, back to the video.
There are records of over 1,200 years of inventors trying to find a perfect machine. The mathematician and astronomer Bhaskara himself, who is not the inventor of the formula you learned with his name, described a wheel that would spin forever. One of the earliest graphic records of one of these perfect wheels comes from the drawing Perpetual Motion by Villa-Ronecourt, a 13th century French artist. The title of the drawing was the medieval version of a misleading title. The wheel certainly did not spin forever. The drawing represents a wheel with free weights attached to the ends. The idea is that as the wheel spins, the weights are thrown from one side to the other in a way that constantly renews the wheel's rotation. Many of these supposedly perfect machines were invented in the following centuries, and they were more entertaining attractions than something important, especially because the world was quite different. Producing and using energy efficiently wasn't a concern until industrialization. The modern history of perpetual motion machines begins with the Industrial Revolution and the invention of engines. From the 18th century onwards, the world began to become more connected thanks to the invention of the steam engine and its main application, trains. And to understand engines, it was necessary to better understand the energy that engines use to move trains. A deeper understanding of energy meant more efficient trains, better factories, and more profit for all kinds of industries. And it was with this very direct and practical goal that the field of thermodynamics began. Thermodynamics is the study of energy transformation and promised to answer mainly three questions. How does energy move a train? How efficient is this process? How efficient can a train's engine be in theory? And I will answer these three questions in the video. But more than that, answering these three questions will reveal some of the most important laws of physics and the universe. And it all starts with a simple engine. In the most general definition, an engine is a machine that transforms energy into work and in the process emits heat. Work is simply useful energy. Energy that is actively moving objects in the world and that we can use in some way. And heat is the opposite. Heat in the context of engines is useless energy. It cannot be used to generate movement. Your car's engine transforms the chemical energy of gasoline into work in the form of the car's wheels rotating and heat in the form of increased temperature. Your cell phone transforms the energy from the battery into electricity, which is the movement of electric charges. And it is this electricity that lights up the screen of your cell phone and allows the processors to function normally. And yes, from a thermodynamic point of view, your cell phone is an engine. And this is where the true power of thermodynamics comes in. We don't need to know how engines work to know how engines work. It seems a bit contradictory, but the point is this. All we need to do is focus on the energy transformations that the engine performs. All that matters are the energy transformations that occur within it. The details are a matter of engineering, not thermodynamics. And that's why answering those three simple questions about engines accidentally reveals two laws of nature that apply to all known natural phenomena without exception. And to start unveiling these universal secrets, we go to the first question. How does the engine work? Since we are talking about thermodynamics in a historical way, let's look at the same engine they studied. The steam engines. High-pressure steam wants to expand. So, if you put an obstacle in the path of the expansion, the steam will move the obstacle, generating work, which is useful energy. In more detail, the process begins with liquid water being heated to high temperatures under high pressure by some fuel. In the case of locomotives, the fuel was coal or wood. The high-temperature steam is directed to pistons, and the pressurized steam moves the pistons as it expands. And in this process, the energy of the hot steam is transformed into motion that turns the train's wheels. And after moving the train, the steam is cooled back into liquid water. Then the water can be heated by the fuel once again to repeat the cycle and move the pistons and the train's wheel. That's how a steam engine works, and we can simplify all of this into just 3 steps. First step, the energy from the fuel is transferred to the water, and it turns into pressurized steam. Second step, the energy of the steam moves the train's wheels, or in other words, is transformed into work. And the third and final step, the remaining energy is lost as heat when the water is cooled to start the cycle again. And it's worth emphasizing the significance of the third step. Not all of the fuel's energy is transformed into motion. Part of it is lost in the process as heat. In other words, if the steam engine wastes energy, it is not 100% efficient in converting the fuel's energy into the turning of the wheels. And just an important note. I know that in everyday life we use the word heat for many things, but when talking about engines, it specifically refers to the energy that is wasted. In the case of steam train engines, only 5% of the energy produced from burning the fuel actually moves the train. So out of all the energy a train produces, only 1 part out of 20 contributes to the train's movement. The rest is just useless heat. It's like eating a plate of food, but for every bite you take, you throw away 19 others. The relationship between energy, heat, and work has a special name, the first law of thermodynamics. And the first law of thermodynamics tells us 3 things about energy. First, energy exists in 2 forms, heat and work. Heat is useless energy, and work is useful energy. Second, the total energy is heat plus work. There is no third type of energy. All energy is either heat or work. And the third and most important point is that energy never comes from nothing. If you want to increase the energy in the engine, you have to add more fuel. This third statement is the principle of energy conservation. And it is this principle that the perpetual motion machines on the internet violate. What does the first law of thermodynamics say? It says that an engine cannot create energy from nothing. All the energy an engine uses must come from some external source, such as fossil fuel or electrical energy. Otherwise, no engine can have an efficiency greater than 100%. It's like trying to squeeze a liter of orange juice from a single orange. One orange alone doesn't have that much juice. But that's exactly what the free energy videos on the internet claim to do. They claim to produce a lot of energy from just a little initial energy. If you saw someone turn an orange into a liter of orange juice, you would think it's a magic trick. And in the same way, any perpetual motion engine or generator has some trick behind it. When we talk about creating energy, we are talking about extracting energy from nature and transforming it into some form of energy that we can control. It is not possible to create energy, only to transform it. And that's what the first law of thermodynamics says. And here comes the question. How can we be so sure that the laws of thermodynamics are true? How do we know that it's really not possible to violate the first law? The main proof of the laws of thermodynamics is not mathematical proofs, but rather centuries of experiments. No physicist, engineer, or inventor has ever found a machine that can violate the conservation of energy or any of the laws of thermodynamics. Moreover, the laws of thermodynamics are applicable to all known natural phenomena today, from biology to chemistry to nuclear physics. In fact, many of these phenomena were only discovered after the laws of thermodynamics. The laws of thermodynamics are one of the most well-proven experimental facts in all of science. Any machine based on a known physical process will adhere to the law of conservation of energy. It doesn't matter if the energy source is chemical, electrical, nuclear, or video editing. No machine generates energy from nothing. Machines that claim to generate free energy are called perpetual motion machines of the first kind, precisely because they violate the first law of thermodynamics. And one of the simplest ways to state the first law of thermodynamics is that perpetual motion machines of the first kind do not exist. But wait, what about the Villa-Ronecourt perpetual motion wheel and all the other perpetual motion machine projects? These machines seem perfectly reasonable according to the first law of thermodynamics. But in essence, what the Villa wheel does is just recycle energy. The energy of the rotation is simply being very well conserved, not created. This does not violate the first law of thermodynamics, only the second. If the first law is sometimes called the law of conservation of energy, the second law could be called the law of energy deterioration. To understand the second law, we will return to the third and final question about engines. How efficient can an engine be in theory? The efficiency of a steam engine is only 5%, but how much can it be improved? Let's assume the maximum theoretical efficiency was 6%. Then, an engine that achieves 5% is practically perfect. But what if it were 50% and current technology only allowed us to reach 5%? This means that our engine is 10 times worse than it could be. So, what is the maximum efficiency of an engine? The first person to answer this question was the French military engineer Nicolas Carnot, and he did this by inventing the best possible engine. In theory, not in practice. Nicolas Carnot created an idealized engine that we now call the Carnot engine. And he proved that any real engine has to be less efficient than the Carnot engine. And not even the Carnot engine is perfect. It doesn't reach 100% efficiency because it also loses part of the useful energy in the form of useless heat. Not even in the realm of theory can an engine convert energy into work perfectly. There will always be some kind of heat loss during any energy transformation. In other words, every engine produces at least a little useless heat, and consequently, sooner or later, every engine stops working if it is not refueled. And this fact is known as the second law of thermodynamics. Every cyclic energy transformation always generates a bit of heat. There are no perfect engines. A perfect engine with 100% efficiency is a perpetual motion machine of the second kind. And one way to state the second law of thermodynamics is precisely that perpetual motion machines of the second kind do not exist. The best possible engine is the Carnot engine, which does not have 100% efficiency. So what is the efficiency of the Carnot engine? The efficiency of the Carnot engine is determined by the maximum and minimum temperatures used by the engine to operate. The lower the minimum temperature and the higher the maximum temperature, the more efficient the Carnot engine is. And the efficiency of the Carnot engine represents the highest possible efficiency for any engine operating at the same temperatures. For example, in a steam engine, the minimum temperature is the atmospheric temperature, about 20 degrees Celsius, and the maximum temperature is something like 300 degrees Celsius, depending on the level of water pressurization. Using these values, a steam engine in ideal situations has an efficiency of more than 50%. That is, an ideal steam engine converts more than half of the fuel's energy into work to turn the train's wheels, which is much more than the 5% efficiency of the first locomotives. Thanks to Carnot's work, we can confirm that steam engines were terrible. So much so that modern electricity generators based on steam have an efficiency of around 40%. That is, 40% of the energy from the burned fuel is converted into electrical energy, and that is very good. And much better than that. Besides giving us a criterion to evaluate how good an engine design really is, Carnot's discoveries assure us that the Villard wheels will stop spinning. With each turn of the wheel, part of the rotational energy will be lost as heat, one way or another. Be it through friction, or the sound generated by the impact of the weights, or other minor effects. Energy is conserved, but not perfectly. Each time the wheel turns, part of the energy becomes useless heat and stops contributing to the wheel's rotation. Sooner or later, the wheel will no longer have enough energy for a complete rotation. And this constant loss of energy as heat is a way of announcing the second law of thermodynamics. The concept of the Villard wheel and perpetual loop toys, like those we constantly see in videos on the internet, represent the quest for a perpetual machine that violates the second law of thermodynamics. And this is the law behind the natural degradation of everything around us. Engines stop working, our bodies age, and all the energy in the universe is slowly converted into useless heat. And this process of energy degradation also has another name: increase in entropy. Entropy is precisely a measure of energy degradation. Every time energy is transformed, entropy incurs a conversion cost and part of the energy is lost as heat. Sooner or later, all energy will be degraded and entropy will reach its maximum. And from then on, nothing else will happen in the universe. All engines will have stopped. All life will have ceased to exist. And even the matter that composes us today will have transformed into low-energy radiation. This is the truth of the second law of thermodynamics. The eternal machines promised by inventors of the past and content creators of the present are an attempt to fight against entropy and its natural increase. If you stop to think, what they all seek is something that lasts forever, something that is immune to the end of the universe and everything that exists. It's not just about entropy or laws of physics being violated. Perpetual motion machines also reveal that humans often have a problem accepting that things have an end. But no matter how much you fight against it, the victory will always belong to the laws of nature. Every engine stops, every work ceases, and every video ends, including this one. But don't be sad. It's part of the natural degradation of YouTube. Thank you very much and see you next time.